In this tutorial, we are going to be taking a look at the natural frequencies for the spring mass system. So here, this example is coming from the Patran post-processing manual. This is going to be problem 14, normal modes, point masses, and linear springs. Here's a diagram of what the spring mass system looks like. And here in the post-processor web app, we have the same spring mass system already created. Here are the nodes. So we have nodes 1, 2, 3, all the way to 6. And then I believe here, let's go ahead and maybe turn off the nodes. And then here you can see that there's a spring between all these different concentrated masses. Let me go ahead and do, I think you get the idea. Here in yellow are the concentrated masses, and here in blue are the various springs. And then a moment ago, we saw all the different nodes that were defined. So this is a very busy model to sum it up. Okay then, so how do we get started on this? Before I go ahead and show you some natural frequencies, let me bring up a few bullet points. Number one, we are going to be using the post-processor web app today, and it's free as long as you are an MSC Nastran user. So if you're a student or professional engineer that's using MSC Nastran, this tool is free for you. Also, the post-processor web app is only compatible with MSC Nastran. If you are using a different version of Nastran, it is not compatible with that other version of Nastran. If you want to start using the post-processor web app for free today, you can visit theengineeringlab.com. In the top right hand corner is a blue button. Click that button, fill out the form, and we'll work with you on getting either an online version of the web app or a installer for the web app where you can download and install the software on your own operating system. Now here, what we're going to do is go to the home page of the web app and click on tutorials and user's guide. And we want to find this tutorial called CONM2 or concentrated mass and CELAS1, natural frequencies, mode shape, and spring mass. Click on that. And then here, let's go ahead and extract the contents of that zip file. So the bulk data file contains the Nastran model for that spring mass system. And then the H5 file contains the eigenvectors or mode shapes. It contains the natural frequencies. It basically contains the results for the Nastran analysis. So what we're going to do now is go back to the home page, and we're going to click on Viewer. We're going to click File Upload. We're going to select that bulk data file. And then here, we'll go ahead and mark both of these checkboxes. So here, in blue are the springs, in yellow are the concentrated masses. Then we're going to upload the H5 file that contains the results. And the first thing we're going to get is the mode shape. So here, let's go and recolor this. So you can see that, let me turn off the mode shape. So this is off and then on, off and on, off and on. So this gives you an idea of what the first mode shape looks like. If you want to know what the magnitude is of the shape or the eigenvector, you can click on marker plot, and then you can click on maybe just the X component, and then you can turn on the shape off and on. And this will give you an idea of what the mode shape looks like. If you go to the next mode shape, so this is what this mode shape looks like. So this is off, before, and then after, before and after. So you can see the concentrated masses are moving, or they're technically not moving, but this is giving you an idea of what the eigenvector, what the mode shape looks like. Another piece of information, you want to know what the natural frequencies are. If you scroll down a little, you get told what the natural frequency is. So here, the natural frequency is about 1.32 hertz. And let's go ahead and look here and see if we get some approximate values. So according to the Patran post-processing manual, the natural frequency for mode 1 is about 0.7 hertz. So let's go ahead and select mode shape 1. So mark this checkbox. And if you look here, we get a natural frequency of 0.69. What about mode shape 2? we get a natural frequency of about 1.32 hertz. Let's look at it for mode 3, was it? So mode 1, 2, and 3. For mode 3, it's about 1.8 hertz. And if we look back here, we're getting the same values. 0.69, 1.32, and 1.8. What about the last mode? What's the natural frequency for that? We're expecting a natural frequency of about 2.14 hertz. So let's go here, select mode 4. And the way we know the mode number, if we look at the mode number column, we have mode 1, 2, 3, and 4. We select this checkbox and we get the data for mode 4. And here we get the natural frequency of 2.14 hertz, which matches the natural frequency here of 2.14. And then here, let's zoom out a little. Let's go ahead and turn off the shape plot. So this is before and then after, before and after. So this is giving us an idea of what the eigenvector or the mode shape looks like. If I want to know the values for the eigenvector, you can mark or turn on this button called marker plot. And then you can select the maximum label. And this will give you an idea of what the values are for that mode shape. Right now we've done this for the X component. Let's go ahead and do it for the X component. So we'll select only the X component. And we'll turn on some labels here. So here you get an idea of what the values are for the eigenvectors. Now, one last comment here. We've seen what the mode shapes are. We've seen what the eigenvectors are. What if you want to output the data to a CSV file? There is this other web app that you get for free called the HDF5 Explorer. Now, this table is useful if you want to create graphs, if you want to create plots. So here we'll go ahead and upload the H5 file. One of the default graphs that are created are for the natural frequencies. So here you can see that for mode 1, 2, 3, and 4, we get the natural frequencies of 0.69, 1.3, 1.8, and 2.14. The same natural frequencies that were mentioned in the post-processing manual. So here, what if you want, you can either download this data to a table. So here, these are the values for the natural frequencies. You can either click download CSV file here, and then the same data is available in a CSV file. If you're looking at the plot and you click this button, view filters and plotted values, you get a new table also. You can also click download CSV here and you get a different format for the table. So here are the 4 natural frequencies. So that was the last thing I wanted to leave you off with. That's how you look at some natural frequencies from Nastran results. As a reminder, the post-processor web app and the HDF5 Explorer are free to MSC Nastran users. It's only compatible with MSC Nastran. If you go to the engineeringlab.com, in the top right hand corner, there's a blue button. Click that, fill out the form, and we'll work to get you either the online access or a installer for the post-processor web app. With that, thank you so much for watching.